Right, hi. So today you will learn about how to simplify, multiply, and divide, and also rationalize your surds, right? So you have to remember these two rules in multiplication and division of surds, and these are, so first one is, you can multiply surds. When you multiply surds, what will happen is you're just multiplying the bases. Okay, so this is only true if the index of your surds are the same. So in this case, this is just a square root and also a square root. So generally, if you have the nth root of A, right, times the nth root of B, okay, that will be equal to the same thing as saying it's the nth root of A times B. So always remember that the index, which is this one, should be the same. Okay, so the same goes through your division, so dividing of surds. So this is only applicable if the index are also the same. So when you divide, so nth root of A divide nth root of B, that gives you the nth root of A divided by B. So take note of these rules. So let's say, for example, by applying these rules, we're gonna simplify the following example. So let's have the first one. So you are multiplying square root of 3 plus 5 square root of 2 times the square root of 2 plus square root of 3. So remember that this is expanding your algebraic expression. So we are gonna use your FOIL method, right? So we're gonna start with the first. So square root of 3 times, this is the same as square root of 3 times the square root of 2, all right, plus outer is this part. So that's square root of 3, all right, times the square root of 3. Inner, which means this one now. So that means plus 5 square root of 2 times square root of 2, and of course the last one, so last and last. So that's 5 square root of 2 times square root of 3. So if you notice, the index is the same, which is just 2, because it's just a square root. So this is just the same as taking square root of 6, because that's 3 times 2, plus square root of 3 times square root of 3 is square root of 9, and square root of 9 is only 3, plus, okay, you have 5 outside, so that is 5 times square root of 2 times square root of 2 is square root of 4, and square root of 4 is only positive 2. Okay, and then the last term will be 5 times square root of 2 times square root of 3 is square root of 6. So that means this can be simplified further by combining the like terms. So 3 plus 10 gives you a 13, plus square root of 6 plus 5 square root of 6. In this case, you only need to add the coefficient, so that is only 6 square root of 6. So this is the final answer. Okay, so that's how you multiply your surds. So we're going to use these method or these concepts later when you are solving equations involving surds this time. So let's have the second example. If you notice, it is just 9 square root of 20 divided by 3 square root of 5. So what happens is, because this is just a normal division, and you see this is just a single term, so we can just say, we can separate it as 9 divided by 3 times square root of 20 divided by square root of 5, isn't it? So that gives us 9 divided by 3 is just 3. And this is the same index, so that means it's the same as taking the square root of 20 all over 5. So in other words, this is just 3 times square root of 4, because 20 divided 5 is 4, and square root of 4 is only 2, so we're going to end up having positive 6 as our final answer. Okay, right? So these are the ways on how you can use the two methods that we did previously. Then my next question is, what if you are trying to rationalize the denominator? So when does this happen? So this happens when, if you notice, the denominator is a surd, but the numerator is not, okay? And then the second one is that the denominator also involves a surd. So if you notice, when do we rationalize is when we are dealing with a fraction whose denominator is a surd, okay? And when we rationalize, we actually just getting the conjugate of the given of the denominator. So let's say, for example, if we have square root of a plus square root of b, the conjugate of that will be, okay, is square root of a minus square root of b. In other words, when you wanted to rationalize, what you need to put in your head is that we are trying to eliminate the surd in the denominator. So we're going to have to get rid of the surd, okay? So that's how we can simplify. So let's see, let's say for item A, if you notice, this is just 2 over square root of 5. So that means in order for us to get rid of the square root of 5, right? How do we do that? We only need to multiply by itself, isn't it? Why do we need to multiply by itself? Because square root of 5 times square root of 5 is square root of 25. Okay, so I'm going to write it here so it's clear to you. Square root of 25. And what is square root of 25? This is just equal to 5. So if you notice, the denominator no longer contains a surd. Okay, for item B. This is the part where you need to use the conjugates. I'm going to write this one up here. This is conjugate. So when to apply the conjugate? When the denominator is more than one term. So in this case, you have 2 plus square root of 3. So this is a binomial. So that means in order to get rid of the denominator, you're going to have to use the conjugate. So that is 2 minus square root of 3. So that's 2 minus square root of 3. You might be asking, why do we need to get the conjugate? Okay, so why is it like that? Remember that when you are multiplying expressions, so let's say, for example, I have an x plus y, right? And I multiply by its conjugate, which is x minus y, okay? Using the FOIL method, this can actually be simplified as a difference of 2 squares. So x squared minus y squared. So in the end, whenever you multiply the conjugate, right, of the given expression to itself, the result is always the difference of 2 squares. So if that is the case, what happens in the denominator is like this. So you see, this is 2 plus square root of 3, and this is the conjugate. By applying this property, we're going to end up having 2 square. You guys notice that? And this is minus square root of 3 squared. So that is the expanded form. Okay? And the numerator is just 5 times 2 minus square root of 3. So notice now that the denominator will become 4 minus, if you're going to square 3, if you're going to square root of 3, you're going to end up having 3, isn't it? So the numerator, just distribute your 5, you get a 10 minus 5 square root of 3. So in the end, 4 minus 3 is 1. So you're going to end up having 10 minus 5 square root of 3 only, right? And for the last one, okay, so you have square root of 7 plus 3 square root of 2 divided by square root of 7 minus square root of 2. Again, this is binomial, so we're just going to have to multiply by its conjugate, which is square root of 7 plus square root of 2. So the same thing for the numerator. All right, so that means, okay, So we're going to have to use your FOIL method here for the numerator. And we're going to have first and first. That means square root of 7 times square root of 7. Or in other words, you're just going to have to square it. Okay. Outer, so that means plus square root of 7 times square root of 2. Okay. Inner is 3 square root of 2 times square root of 7. And then the last one, oops, I don't have enough space, is 3 square root of 2 times square root of 2 is just 2. So I simplified already the last part. So the denominator is going to be square root of 7 square minus square root of 2 square. You see, we're applying this rule, right, for multiplying expressions. So in the end, what we're going to have is square root of 7 squared is just 7. Square root of 7 times square root of 2 is just square root of 14. Okay. And then this one is plus 3 square root of, again, is also 14. 3 times 2 is just 6. Denominator is just 7 minus 2. So in the end, we're going to have 7 plus 6 is 13 plus square root of 14 plus 3 square root of 14 is just 4 square root of 14 all over 5. Okay? So notice when we rationalize, the denominator becomes just a number, does not contain a surd anymore. So that's the purpose of rationalizing your denominator. Okay, so how are we going to apply this using past year questions? So let's have these ones. So how are we going to find your tangent of theta? So in this case, you have to recall your trigonometric ratios because you're dealing with right angle triangle. So if this is your angle x, tangents, remember your SOHCAHTOA. SOHCAHTOA. So if you're dealing with a tangent, that means you're dealing with TOA, right? So tangent, TOA means tangent is just equal to the opposite over the adjacent. That means if you're looking for tangent of x, so I'm going to replace it here now. So tangent of x is equal to the opposite side of x is this, and this is the adjacent side, right? This is the hypotenuse with respect to x here. This is the opposite, and this is the adjacent side. So that gives us 3 plus square root of 2, okay, divided by 1 plus 2 square root of 2. Okay, so since we're looking for tangent theta, and if you notice, the denominator is a binomial that includes surd, so we're gonna need to rationalize the given equation or expression. So that will give us 1 plus 2 square root of 2 is, the conjugate is 1 minus 2 square root of 2. So that is 1 minus 2 square root of 2. So therefore, this will give us, multiply again, use your FOIL method, 3 times 1 is 3, okay? Then outer, so that's 3 times negative. So that gives us negative 2 square root of 2. So I'll just put 3 times 2 square root of 2. Why is it negative? Because it's a minus here. And then inner is plus 1 times square root of 2 is just square root of 2. And then the last one, you see negative and positive becomes negative. Square root of 2 times 2 square root of 2. Divided by, okay, denominator is just 1 square, which is 1. So I'm just going to put 1 square first. Minus 2 square root of 2 square. Okay? All right, so now we can simplify your numerator. Your numerator becomes 3 minus 6, square root of 2 plus square root of 2 And then this gives us minus 2. Square root of 2 times square root of 2 is also 2. So that gives us a 4 in the end. And the denominator is just 1 minus. If you're going to square this, you're going to square each of the terms here. So 2 times 2 square is 2. And this one is square root of 2 square is also 2. So that means 2 square is 4 times 2. That gives us positive 8. Okay, so that means your tangent, we can simplify it here. I'm going to put it here. So 3 minus 4 is negative 1. I'm going to write negative 1. Negative 6 plus 1 gives us a minus 5 square root of 2 divided by negative 7. So I'm going to get rid of the negative. So that gives us 1 plus 5 square root of 2 divided by 7. So that is your tangent. So here your A is 1, your B is 5, and your C is positive 7. Okay, so that is the solution for item A. For item B, hopefully I have enough space. Find the area of the triangle. Okay, area of the triangle. Remember, this is a right angle triangle. So area is just 1/2 base times height. So therefore, the area will become 1/2. The base is just 1 plus 2 square root of 2. And then the height is just 3 plus square root of 2. Okay, so this is just purely a multiplication. So that gives us 1/2. Use your FOIL method again. 1 times 3 is 3. 1 times square root of 2 is square root of 2. 2 square root of 2 times 3 is 6 square root of 2. And then the last one, 2 square root of 2 times square root of 2 gives us a 4. Okay, so this can be simplified as 1/2 bracket 7 plus, this becomes 7 square root of 2. In other words, we can simplify this as 7 over 2 bracket 1 plus square root of 2. So that is our final answer.